Core making is part of foundry practice and is closely related to the molder's trade. Cores are separate shapes made of sand which form holes, cavities, or pockets in the castings. Cores are used in the production of most castings. Patterns determine the shapes of castings, but without the use of cores, such pieces as these would be solid, requiring expensive machining to remove material and form the necessary hollow spaces. The present job is to make a small cylindrical core which is used to form such a hole as this in the center of a cast iron wheel. Coarse sand is of different composition from molding sand. It should produce cores that are refractory or heat resisting, permeable to allow gas to pass through them, strong enough to withstand the flowing of metal into the mold, but readily collapsible so they can be removed from the rough casting. A good core absorbs a minimum of moisture and produces a minimum of gas. It should impart a smooth surface to the casting formed around it or by it. Core making requires a clean, sharp-grained silica sand with little or no clay. Binders are added to hold the sand together while damp and to make the core strong after drying. Oil binders may be linseed oil or commercial core oil, which may be used alone or in combination with cereal binders such as corn or wheat flour. The amount of binder used determines the strength of the cores. This sand has been tempered to the right consistency. If core sand is too dry, the baked cores will be weak and will tend to crumble. Sand that is too wet will stick to the core box and the cores may sag before baking. Experience will enable you to judge when the sand is well tempered. In starting the job, select a core plate of a size that will hold the cores to be made without wasting space. A good core plate provides a flat surface and resists warping in the heat of the core oven. One method of making small cylindrical cores is to use a two-part core box. Be sure that it's clean. Then fit the halves together and clamp them. This type of box is set on end for ramming. In order to get the sand firm, it should be added a little at a time and well rammed with a rod. Repeat this until the core box is filled. Then strike off the surplus sand and vent the core. In this case, a vent wire thrust through the center of the core will form a channel for the escape of gases. Now, after removing the clamp, stand the box on the core plate, wrap it lightly and carefully remove one half. Then slide the core into a position where it will not waste space on the core plate. To use oven space efficiently, each core plate should carry a maximum number of cores. Another method of producing similar cores is to form and bake them in two parts, which are then pasted together. In this case, the core box represents one half of the core. Be sure that it's clean. Fill the box and use your fingers to tuck the sand well into all corners and pockets. Then ram it with the heel of your hand. In the case of a small core like this, use a trowel to strike off the surplus sand a little at a time so as to avoid pulling rammed sand out of the box. Now flop the box. This compacts the sand just enough to permit drawing or rolling back the core box without tearing the edges of the core. The other half of the core is made in the same way in the same box. When making cores in this way, it's essential to have a symmetrical core box so that the core halves will match accurately. The green or unbaked cores are now ready for drying, which will develop their strength and permeability. This is done in a core oven. Here, depending upon the size of the cores and the type of binder used, normal baking temperatures range from 350 to 450 degrees Fahrenheit. When they are removed from the oven, the cores should be thoroughly baked. Although those made with cereal binders have greater green strength than those made with oil binders, the cereal binders have a tendency after baking to absorb moisture from the atmosphere or from the mold. A damp core creates steam at the time of pouring and may cause a core blow. To complete these cores, the flat sides of two halves are first rubbed together just enough to ensure a fit. Then the vent channel is cut. Scrape a narrow groove through the center of the flat side of one half. The channel thus formed will permit gases produced in the core during pouring to escape to the vented molding sand that will surround the core in the mold. Now paste the halves of the core together and seal the joint. If an air drying paste is used, the cores need not be returned to the oven to dry it out. In spreading the paste, avoid using too much or allowing it to clog the vent channel. To appreciate the importance of good core making, it's necessary to understand how a core is used and what's required of it. The function of the core is to keep the molten metal from filling in those parts of the casting which are designed to be hollow. On patterns for gray iron castings, core prints and the outlines of the core are painted yellow. Core prints, which extend beyond the pattern itself, are to locate and support the core in the mold. To permit the escape of gases through the vent channel in the core, the molder runs a vent wire through the sand at the center of each core print. This extends the vent from the core into the molding sand at each end. Then the core is centered carefully in the core print, and when the mold is closed, the vent channel in the core should be perfectly aligned with the vent holes in the mold. The qualities of the core are demonstrated when the mold is poured. cross-section view of the mold reveals its interior arrangement. Vents in the drag extend almost to the lower side of the mold cavity. Similar vents are provided in the copes, except in the area directly below the pouring basin. A cross-section of the core, supported by the core prints, reveals the vent channel through its center, connecting with the vents in the core prints at its ends. Fillets at the lower ends of the pencil gate and riser will help prevent the flow of metal from tearing away the sand. When pouring starts, the pouring basin is filled. Slag floats to the top, and clean metal flows from the bottom of the basin into the mold. The heat of the molten metal immediately produces steam and gases from the molding sand, and the vent holes which the molder has made will relieve the resulting pressure. Additional gases which are generated in the core permeate through it into the channel at its center and are conducted away through the vents provided in the core prints. In review, every core maker should know what properties are desirable in cores and how sand is prepared to make cores having those properties. Always see that core sand is properly tempered. If it is either too wet or too dry, it will not produce good cores. Tuck the sand well into all corners and pockets of the core box, so as to make strong, sharply defined cores. Remember that firm ramming of the sand in the core box is essential in making a good core, and that this is true whether the core is made in one piece or several. An efficient core maker always plans to use oven space to advantage by selecting core plates of appropriate size and filling them to capacity. Always be sure that the cores you make are adequately vented, either before baking or, in cores of certain types, after drying, but before assembly. In assembling cores, be careful to see that the parts fit accurately and that vent channels are kept open. Conscientious attention to these principles will help you to turn out cores that will meet the one essential test: the production of smooth, accurate cored surfaces in the castings where they are used.